Okay, a simple request was made, and reasonable, is that we possibly want help with this. Okay? Man, it's pretty quiet in here. Is that because track students are gone? Oh, remember, I got to keep, I didn't quite fully erase this, but I'll fill that in with my artistic abilities. Okay? So your reasonable request was what?
To go over synthesis, combustion, and decomposition.
Okay? And that's not what today's evaluation is over. Today's is just balancing. You don't have to balance out compounds or molecules. They are already provided. You just have to balance what's on the left-hand side of the arrow, which is what? What's on the left-hand side of the arrow? The reactants. What's on the right-hand side? Okay. So if we were to do a decomposition, because I think that's the one you said first, decomposition. Okay, that's when something or some compound or molecule is going to be broken apart. So we can do this because this is also part of prior knowledge that we do know, correct?
Yes.
Okay. Okay, so for those of you who perhaps in a couple of years decide to take general chemistry, some of this change. You just won't know this as hydrogen chloride. Depends if it's a gas or if it's in a liquid state. Because if it's in a liquid state, chances are you're talking about the acid, not the gas. Okay, so in this case, regardless, what is hydrogen? Symbols.
H.
Okay, what is the chloride ion?
Cl.
Now, what I had said earlier is the compounds are provided, but that is not the case if it's in word form. You are going to have to be able to write out the compounds if it's given in word form. So what do we notice on this side? Here we have a compound. What is on the right-hand side? Products, but more importantly, what? No, not water.
The same thing.
What is hydrogen?
H.
And then, what is that?
Cl.
And there's a plus sign in between them. And before we proceed, okay, now we've got everything where it belongs. How many people believe this is balanced? Why not?
Because hydrogen needs a 2, because it's a what's it called? Diatomic.
Okay? Okay? Okay, question was, reasonable one. How do we know if it's diatomic?
Because it's a gas.
If it's a gas.
If it's not a noble gas.
And it's not a noble gas. That's not quite all of them.
Yeah.
There's still one more. And why is iodine important? You're right. I know it's diatomic. No, it's not a gas. It's a liquid. Can be a liquid.
Because it can combine with each other.
No.
Because 2 of them.
It's a halogen. As I say, its placement on the periodic table. We know that halogens in gases are diatomic, except for, like you correctly said, the noble gases.
What if you don't know if it's a gas or not?
Well, we could apply common sense. See, that's something that we can do too. Just look anywhere on that periodic table, whether it's yours, okay, or whether it's one that we see over there. The one on the wall is actually a little more specific, but someone pick a substance that is not a gas. Yeah, aluminum's not a gas. Why not? Because it's a metal, okay? What else is not a gas? Silver's not a gas because, again, it's what? Okay? So what might be something that's just a little bit closer to the halogens or gases, but is neither, is still a solid or even a metalloid. Take a look. That is really close. Lead is, yeah, we could say that, but is it a noble gas? No, it's still a metal. Okay? So let's apply again our common sense and look at the periodic table. What are some gases? There's one up there already. Hydrogen's one. Yeah, it's already up there.
Noble gases or no? Or just gas?
No, it's just gases. So hydrogen's one. Okay, chlorine's a halogen, which is still a gas too.
Oxygen?
Oxygen's a gas. Nitrogen's a gas.
Carbon?
Carbon is not a gas.
Really? Darn it.
Well, why do you think you're writing on that paper? That's not gas coming out of your pen or pencil.
Oh.
Lead, graphite.
It's graphite, which is carbon. Okay? So you can just know that anything in column 7, with the exception of astatine or AT, anything above that, and the gases, but not noble gases, like from top to bottom, helium, okay? Then it's neon, then argon, then krypton, then xenon, then radon. Those are not noble gases because they are highly stable. All right, that's enough time we want to spend upon that. Now you just need to balance this. Is this difficult to balance?
No. Just gotta fix it.
You're done.
2, 1, 1.
Okay? Because what can happen is, notice, when things break apart, that is decomposition. Can we go that way? Which means now what has happened? You didn't break them apart, you put them together, which means what? That is synthesis. That's right. So these two are synthesis reactions. But let's put this back to where it belongs. Synthesis and decomposition reactions are opposites of one another. Decomposition means it's breaking apart. Synthesis means you're putting them together. All right? And the same thing would apply. You just need A2 there, and that is balanced. Okay. We've got time for one more question.
Combustion?
Okay. So, how do you know you're looking at a combustion reaction? We gave multiple clues and or ideas on how to categorize a combustion reaction.
Has hydrogen and carbon?
Okay, so this is not rocket science. A hydrocarbon means it's got what two elements in it? Hydrogen and carbon. Okay, so there is our hydrocarbon. You are combining that with what in a combustion reaction?
Hydrogen?
No,
Oh. Metal?
no,
Water.
no.
No.
The example we gave
CO2?
was the idea of anyone who's ever had to light candles on the altar. Those candles are going to continue to burn until they have what taken out of it?
Oxygen? CO2? Oh.
Okay, what's true about oxygen?
It's air?
It's a gas. So if it's a gas, it is diatomic. Okay? Then another characteristic of a combustion reaction means what is always on the right hand or product side. Always.
H2O?
That's one.
Carbon? CO2?
So typically we write them like this, and then that is a combustion reaction. We know because it's got a hydrocarbon, it's combining with oxygen and giving you the same byproducts. Okay? But one last aspect we need to do with that hydrocarbon. You need to pick a and or two, or pick a number. Okay? Which means this is going to be 18 then.
It has to be 10 more than the other.
Not necessarily,
So how do you figure out what hydrogen is?
because I told you.
Oh, okay.
Because next chapter, you won't just know it by this, we will start the organic portion.
Well, that's fun.
1, 2, 3, 4, 5, 6, 7, 8. Okay? And a little bit of a review. What column is carbon in? So how many bonds does carbon want if it's in the fourth column? That's why each and every carbon you look at has 4 bonds. This one to that one is 1 bond and 3 hydrogens. This carbon is bonded to that one for 1, this carbon to that one for 2, and then 2 hydrogens. There's its 4 bonds. Okay? Then you go all the way through the compound. How many do we see? Well, there's 8 of them. 1, 2, 3, 4, 5, 6, 7, 8. So a hydrogen on top and the bottom. 8 times 2 is what?
16.
And then count your ends. Gives you 18. Okay? So one of the things we said, getting to the organic portion, that is perhaps some people really like it. Some people say this is very, very difficult. And I don't know where you stand upon that. The applications for organic are probably a little more recognizable and extensive than inorganic chemistry is what we're doing right now. Okay, how can you help yourself out here?
It's even, so you have to put 2 in front of
Okay, when we recognize these, now, that's not true all of the time, but it's true the majority of the time. Okay, because what do we know about something like ethanol? Okay, is that flammable? That's highly flammable. This is octane. This is highly flammable. So my point is, when you're talking about ethanol, that's got a little bit of oxygen in it. So that can be flammable as well. So it's not always the case, but the majority of the time. Okay? Just like maybe a way of looking at that, if you do not like bugs or insects, if they creep you out like very big cockroaches, okay? It used to be that maybe cockroaches could be the size of this textbook, okay? You're looking at pre-Cambrian period time frames on this Earth, which means the oxygen content was way higher than what it is now, okay? So insects could grow quite large because if there's enough oxygen in the atmosphere to fuel their demands, they could grow larger. We can try that now. You can try fueling a closed system with oxygen to make insects grow bigger. No, we're as big as we can get. So just because you keep adding oxygen to a life form, it can grow bigger, but it doesn't mean that it's going to. Okay? Now, the reason that we say, can we grow bigger? No, we can grow about as high as about 7 feet, 9, 7, 10. Once you start growing into the 8 feet area, there's just too much stress put on your body. Well, just grow your body bigger. Well, the bigger you grow your body, then you're putting even more stress on that. And you can say, well, have bigger muscles, bigger bones. It takes a lot of effort to fuel those demands. And again, there probably isn't enough oxygen to fuel that.
So,
Probably.
sure, if we put like a cockroach in a room with like a lot of like high oxygen levels, then it would just get bigger?
No, that's not what we said. We said that you can do that, and just because you have that oxygen doesn't mean that it's going to grow bigger. And you have to take into account Mother Nature had about probably 300 million years to work on that. We can't do that in just a couple of days. Okay, so this is where the math gets to be a little difficult. Okay, once you recognize that and put a 2, okay, what's 2 times 8?
16.
Okay, it is. 2 times 8 is 16. How many carbons do you see on the right?
1.
And how do we get that up to 16?
Put 16 in front of it.
Okay, now let's not get so wrapped up with our oxygens. This just comes with experience and practice. Do your carbons first, then do your hydrogens. Because what is 2 times 18? 36. So if 2 times 18 is 36, what did you have to multiply that to get to 36? 18. So if we take 18 times 2, that will give us 36. Okay? 18 and 2, 18 and 2. Now, your oxygen, 16 times 2, 32. 18 times 1. 18 plus 32 is what? 50. 50 divided by 2, 25.
Wait, how did we get that? Oh, that was a little too fast for my brain.
16 times 2. 18 times 1. 18 plus 12. 50. 50 divided by 2. 25. Okay, we probably better get rolling here. All right, so there's a quick review for you. Balancing tomorrow for those of you in track. We're going to do your classifying tomorrow, and then next week you just have to get caught up on what we did today. We'll catch up to you next time.